Computers these days can do so much, but how can they even understand anything we instruct them to do when they only understand two digits, 0 and 1? Information goes into a computer in our language, but comes out the other end as zeros and ones. There has to be something in the middle to translate this data. For this, we use what is known as a character encoding scheme. A common example of this is ASCII. ASCII stands for the American Standard Code for Information Interchange. But ASCII only translates the English language and isn't compatible with other languages. It can only translate A to Z in uppercase, A to Z in lowercase, digits 0 to 9, symbols such as exclamation point, question mark, full stop, comma, inverted commas, colon and semicolon, and other symbols. Altogether, ASCII translates 128 different characters. ASCII began being developed in 1960. The first edition was published in 1963. In 1967 it underwent major changes, and now the most updated version is the 1986 one. How does ASCII work? Well, ASCII is a 7-bit code. At the time ASCII was developed, many computers dealt with 8-bit groups. This was their smallest unit of information. The 8th bit was used as an extra bit for error checking. To find out what each English character is identified as in ASCII and in binary, we can refer to the ASCII table. For instance, lowercase a can be identified as 097 in ASCII and 011000001 in binary, while uppercase A can be identified as 065 in ASCII and 0100001 in binary. Each code is unique and therefore there can never be any overlap. But what about when different languages and uncommon symbols go into the computer? ASCII won't even recognize them. Because of this, there are many disadvantages associated with using ASCII. It's basic, limited, and it cannot be used in different speaking countries. This is why Unicode was invented, as a solution to the problem. It was in 1987 that investigations began for Unicode. It was clear that a universal character set would be beneficial worldwide. In 1988, a draft proposal was published. It was revealed that Unicode 88 would use a 16-bit code, which was a big step up from ASCII, which only used a 7-bit code. Unicode has been developed and updated upon over the years, and the most updated version of Unicode now contains 110,000 characters covering 100 scripts. Before Unicode was developed, there were hundreds of different encoding systems all over the world that had to be used for all different types of languages, and that was just really impractical. Not to mention, there was a lot of overlap between all of these different computer systems. It often happened that the same code was used for two different characters. Unicode therefore fixed all of these problems. Unicode provides a unique number for every single character, regardless of the platform, program, or language. It is also the industry standard used today. From this presentation, it is clear which one is better in the argument of ASCII versus Unicode. ASCII is limited and is impractical, whereas Unicode is obviously better because it covers everything. Other advantages of Unicode include the fact that it is cost-effective, that data can be transferred over to other countries without file corruption, and the fact that one website can be targeted worldwide without re-engineering. Here is a list of the references I used for this presentation.